Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a really nice problem, an exponential equation with complex numbers. If you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel called Cyber Math, that is cyber with an S. Also go ahead and check it out. I publish twice a week on that channel and once a week on this channel. And let me know what you think. Great, so now we have this complex number, A plus BI. By the way, that's also the name of this channel, which is really cool, right? Raised to the power 2026. So if this was a competition problem, it must be from this year, right? And of course, that power turns it into B plus AI, which kind of switches the places of A and B, right? And how do you achieve that? Let's go ahead and go through this problem. How many solutions do you think there are? Go ahead and try to guess, and then we will continue. Okay? So, step one is going to be, we're going to go ahead and write the right-hand side using the complex conjugate of z. First of all, let's talk about complex conjugates. And again, if you're new to complex numbers, go ahead and check out my lecture videos and ask a lot of questions. So if this is z, then z bar, which is the complex conjugate, would be a minus bi. Well, that doesn't quite give us b plus ai. What happens if we take z bar and multiply by I? Then we use distributive property. Oops, I forgot to say that. I squared is equal to -1 because I is the square root of -1, right? Hopefully you knew that. Now here, if you distribute, you get ai minus, not artificial intelligence, just ai, and then minus bi squared. Since I squared is equal to -1, this gives us ai plus b, or b plus ai. We usually like to write the real part first and then the imaginary part, which is a. Make sense? So I was able to turn a plus bi into b plus ai by conjugating it and then multiplying by I. That's the type of transformation you need to perform to get our equation. So if a plus bi is equal to z, as we assumed before, from here we get b plus ai as I times z bar, which is the complex conjugate. Great, let's go ahead and plug this into our equation, right? Well, this gives us basically z to the power 2026 equals I times z bar. Beautiful. Now, first of all, we're going to work with magnitudes, in other words, absolute values, or moduli. What is the modulus of a complex number? When you plot a complex number in the complex plane, which is the Argand plane, you basically get a distance from 0. That distance from 0 is considered the absolute value. This is called the argument theta, so on and so forth. And this basically allows you to write it in polar form. Thanks to Euler, we have this beautiful, the most beautiful equation in math that relates a trigonometric expression with I to an exponential. Okay, but let's go ahead and work with the magnitudes or absolute values first. I'm going to go ahead and take absolute value on both sides, because if two numbers are equal in the complex world, their absolute values are also equal, obviously. We're talking about the same number. Come on, right? Now, when taking the absolute value, obviously, you can pull this number out. Since 2026 is an integer, we're able to do that. And if you have a product, you can actually separate those absolute values. The absolute value of z1 times z2 can be written as absolute value of z1 times the absolute value of z2. Great, but the absolute value of I is just 1 because I is 1 unit away from 0, and the absolute value of conjugate of z is the same as the absolute value of z. This gives us a beautiful, beautiful equation. Let's go ahead and set the absolute value of z equal to r. This gives us an interesting equation. R to the power 2026 is equal to r. Isn't that awesome? Let's go ahead and solve this by factoring. Do not divide by r, but rather subtract r from both sides and then factor out r, and then you will get the solution. And again, I'm going back to the question that I asked you before at the very beginning. How many solutions is this equation going to have? Go ahead and try to find that at this point. Okay, now what do you think can work here in terms of r? Well, first of all, if r is 0, this will be fine. So case 1 is r equals 0. But remember, the only complex number whose absolute value is equal to 0 is z equals 0, because all other numbers have a non-negative, non-zero, or should I say just a positive absolute value. Okay, so 0 definitely follows from here. What about if r is not 0, then r will be 1. That's basically the second case. So this is what we're going to be more interested in. So the first one is kind of like very trivial. That's just 0. And obviously, if you go back and set a and b both equal to 0, right, then you're going to realize, uh-oh, this equation definitely works. But that's not very interesting, is it? Let's go ahead and go with this. R equals 1. What does that mean? Well, let's go ahead and find out. If the absolute value is 1, we can definitely write a complex number, as you know, in polar form. Z equals r times e to the I theta. But since r is 1, we can just write e to the power I theta, which is awesome. Theta is the argument, by the way. Remember the angle, the positive angle that it makes. But more importantly, for our number, let's say z is equal to e to the I theta. What is z bar, right? Z bar is basically when you kind of reflect it along the x-axis or the real axis. And the only thing that changes is the angle is basically negated because cosine of negative theta is also the same as cosine theta. You can also think about it as first and fourth quadrants. That's what we get. Okay? That's going to be the z conjugate. Great. So now we got z and z bar. Let's go ahead and plug this in. By the way, we also have an I, so we also need the polar form for I. And you can basically write it as e to the power I times pi over 2. Because remember, I is right here, and it makes an angle of pi over 2 radians with the real axis, which is the x-axis. Okay? So far, so good. Now, let's go ahead and plug in everything. Of course, we're going to take z, e to the I theta, and then raise it to the power 2026. And that's going to equal I times z bar. And I is going to be e to the power I pi over 2. And z bar is just going to be e to the power negative I theta. Great. Now let's go ahead and put it all together. This is going to give us e to the power I times 2026 theta is equal to e to the power I times pi over 2 minus theta. Since both sides have I in them, we can basically forget about I in this case and set the angles equal to each other. So from here, we get, and by the way, you can do something that would make your life a little easier. Multiply both sides by e to the theta after you cancel out the i's, because that will get rid of this e to the power negative theta. So you'll have e to the power 2027 theta equals e to the power pi over 2. Does that mean 2027 theta is equal to pi over 2? So we're going to get a single value? Nope. We're going to get more than that. But let's go ahead and see how we can solve a problem or this problem from here. So basically setting the exponents equal to each other, but consider the fact that these are equivalent modulo 2 pi, right? So it's going to be like this. 2027 theta is equal to pi over 2, but you're allowed to add multiples of 2 pi, because if you sine, cosine, whatever you do with those numbers, you're always going to get to the same angle. Even if you don't, it's going to give you full rotations, basically. So I'm going to write 2 pi n, where n is an integer. Could be negative or positive. So far, so good? Great. Now, let's go ahead and solve for theta from here. How do we solve for theta? Well, first of all, you can make a common denominator on the right-hand side. That's going to give you pi plus 4 pi n all over 2. And then maybe you're going to factor out the pi, and that's going to give you 4n plus 1 pi over 2. So it's kind of like a number that leaves a remainder of 1 when divided by 4, like numbers that are 1 mod 4. And then, of course, you're going to divide them by 2, and they're going to be odd numbers. So you got to be very careful. Now, at this point, we can go ahead and multiply both sides by 1 over 2027, or divide by that. So theta would be 4n plus 1 multiplied by pi divided by 2 times 2027, which is 4054. Again, n is an integer. So if you go ahead and take n equals 0, for example, from here theta is going to be pi over 4054. And of course, z would be e to the power I theta, which is e to the power I that. And this is equivalent to cosine theta plus I sine theta, thanks to Euler again. Oops, I was supposed to write theta, but I wrote pi. There, here we go. This is the most beautiful equation. And of course, you can replace theta with that. And Good grief. Try to find the value of cosine of this angle, and that should give you the answer. But we can leave it at that, definitely. And guess how many values we're going to be getting from here by replacing, theta or k with 0, 1, n with 0, 1, 2, all the way to 2026. It's going to give you how many solutions? 2027. And along with 0, that's going to give you how many solutions? That's going to give you the whole total number of solutions. So we have 1, 0 solution, 2027 solutions on the unit circle. There's a total of 2028 total distinct solutions. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.